Good morning. Myself P. Revati from Department of IT, Hindustan College of Engineering and Technology. Going to share the content on digital principles and system design. In this video, I am going to discuss about the combinational circuits. Coming to the introductions about the combination circuits. Generally, this is a logic circuits which is having the different logic gates inbuilt in integrated in a circuits. Generally, the combination circuit is a circuits whose output will depends upon the input variables. It can have n number of the input variables and you have m number of the output variables. And these circuits do not make use of any memory or storage device. Coming to the contents, we are going to discuss about the adder and half adder. Coming to the adders. The adders are the basic building block of the any digital electronic device that implements addition of numbers. In many computers and other kinds of processors, adders are used not only in arithmetic and logic units but also in other parts of the processor, where they are used to calculate addresses, increment and decrement operators, and similar operations. The adders are different types, starting from the half adder and full adder. Let us first take a look at the additions of the single bits. 0 plus 0 means 0 with no carry, and 0 plus 1 is 1 and with no carry, and 1 plus 0 is 1. This is also with no carry. And 1 plus 1 is 1 0. That is, sum is a 0 and carry as the 1. Coming to the half adder. What is meant by half adder? Half adder is a combination circuits designed to add two single bit numbers, which is going to add two single bit numbers. It contains the two inputs and two outputs. Our half adder is going to add only the single bit numbers. That single bit number I represent A and B, and two outputs may be the sum and carry. The next step is we need to define two table. The two table is contain the two input variables and the outputs. With the two input, you know that you have four combinations, that is 0 0 0 1 1 0 1 1. These are the possible four combinations for two inputs. What is the sum of the 0 and 0? That is a 0 only. In normal arithmetic operations, add no carry. So S equal to 0, C is equal to 0. When we are adding 0, 1, the sum value is a 0 and carry is a 0. Now we are adding 1, 0. So the sum is a 1 and carry is a 0. In arithmetic operations, the 1 plus 1, the sum is a 0 and carry is a 1. Now, after getting two table for our record relationship, we need to consider KMF for each output variables. Now I am taking KMF for sum. Let's group the terms. Well, no grouping here, and write the expression for these terms. This is a and B bar. Since A is a 1 and B is a 0. So I'll write the SOP form, that is the sum of the products. We represent it as A and B bar. This term here is A bar and B. We will take both the terms and sum them, thus writing the sum of the product expressions. A and B bar or A bar and B is nothing but the A XOR B, and that is our sum expressions. In same way, I'm going to consider the K map for carry. Here, one is present for A and B. The expression for carry is A and B. Coming to the analyzing results, you have the two inputs and two outputs. The inputs are A and B. The outputs are sum and carries. The sum can be obtained by using XOR logic gates, and the carry can be obtained using AND gates. After getting the K-map, you draw the logic diagram. Coming to the logic diagrams, I am considering A and B lines to get the sum from the two input variables. So you need to take XOR gates. That means A XOR B. So I am considering the XOR gate to get the sum. And same A and B. If you consider AND gates, you are getting the carry. Thank you.